today we will learn about this laboratory preparation of some important salts. Okay. So what do you mean by Mom, your voice is cracked. 1 minute now? No, it's fine. Okay, so first is the laboratory preparation of the iron chloride. Okay, iron 3 chloride, which is the chemical formula is FeCl3. So here, don't use phone. So here, what we have to do is like it is also called as a ferric chloride. Your iron chloride is also known as what? Because the one more name of iron is what? Ferrous, है ना? Ferric. So it is also called as a ferric chloride, which is an industrial scale chemical compound, which is what? Which is used in very industries. So when we dissolve this ferric chloride in a water, what will happen? Iron chloride will undergo into hydrolysis and it will evolve heat, which is what? So this process is known as what? Exothermic or endothermic reaction. Because if something is going on, it is evolving heat, so it's an exo or endo reaction. Exothermic. Good. Exothermic reaction. So when the iron chloride is dissolved in water, it will undergoes into hydrolysis and it will evolve heat. Now, how to prepare iron chloride? So here it is prepared by the reaction of iron with a chlorine. So what we have to do? We have to react the iron with a chlorine. So 2Fe plus 3Cl2, this is a balanced equation. And if I'm reacting this iron with a chlorine, what is happening? What is forming? FeCl3, which is your ferric chloride. Simple. Iron with chlorine, what will form? FeCl3, 2, 2 and 3. Okay. Now, what is the procedure of this iron chloride? Now, we'll look into preparation, reaction also we did. Now, what's the preparation as procedure? So, in a combustion tube, so this is, let's say this is a combustion tube. Here what we have to do, thin wire of iron is placed. ठीक है, thin wire जो है वो iron का यहाँ पर place करा जाता है. So initially what will happen? The dry chlorine gas is passed through the combustion tube. This is your combustion tube. So here what is happening? Your dry chlorine gas is passing through this combustion tube. And here what is this? This is the iron wire. So the combustion tube is slowly heated for a few minutes. So what will happen? This is your combustion tube. This will slowly heated for some minutes, for a few minutes, and the dry chlorine gas will pass slowly through this beaker and then into the iron wire. So what will happen? The iron turns to be very hot. This iron wire turns to be very hot, which will result as a exothermic reaction. So what is happening again from the starting? What is iron chloride? It's a FeCl3, which is also known as ferric chloride. So here what we have to do, when this ferric chloride is dissolved in water, it will undergo into hydrolysis and evolve heat. So this whole reaction is known as the exothermic reaction. How to prepare this, Riya? How to prepare this? What? How to prepare this iron chloride? Ma'am, can you hear me? Huh. Ma'am, what was the question? How to prepare iron chloride? Ma'am, can you explain again? Okay, but focus. Okay. So preparation is what we have to prepare this by reacting with the iron and chlorine. This was the simplest one. Only we have to do with the help of it two substance, iron and chlorine, and then FeCl3 will form. And now what is the procedure of this? So here this is a chlorine. So when this dry chlorine is passed through this tube, and here what is this? This is the iron wire. So when this dry chlorine is passed through this iron wire, so what will happen? Your iron wire also like turns to be very hot, and this will result into a exothermic reaction. That's why this whole process of a iron chloride preparation, reaction, procedure, all are what? All are a exothermic reaction. ठीक है? एक बार फिर से again once again. So here iron is a ferric, it's a exothermic, reaction is ferric, like iron and chlorine. We have to pass this Cl dry chlorine with this tube to the iron wire, and this will also turns very to be hot, and this will result in exothermic. Okay, so now the second one is a copper sulfate, which is CuSO4. So it is also known as blue vitriol. and this iron chloride is also known as ferric chloride. Okay, so this remember. So iron chloride is also known as ferric chloride, and this copper sulfate is also known as blue vitriol. So how to prepare copper sulfate? Copper sulfate can be easily prepared by treating copper hydroxide, copper oxide, or a copper carbonate with a dilute acid. So it's also easy. What we have to do, we have to treat this copper hydroxide, or you can take copper oxide or carbon carbonate with these dilute acids. Okay? And then what will form? C. CuSO4, CuSO4, Cu, CuSO4. All are what? Blue vitriol. So how to prepare this? By treating the copper. This is your copper hydroxide. This is your copper oxide. This is your copper carbonate, and this is your copper sulfate. By reacting with the dilute acid, what we are getting? We are getting a blue vitriol. Now, what's the procedure for this one? So here to prepare the here to prepare the copper sulfate, what we have to take? We have to take the dilute acid, which is your H2SO4, in a beaker. So let's say this is a beaker, and inside the beaker there is H2SO4, which is your dilute acid, and heat on the wire gauze. And what I'm doing, I'm heating this beaker on a wire gauze. So add copper hydroxide. What we have to add? Copper hydroxide. See, this is your copper hydroxide now. So we have to add a copper hydroxide and keep stirring the solution. So in this beaker, dilute acid is present, and what I'm taking a copper hydroxide and stirring the solution. Okay? So after that, what will happen? And we'll keep the solution to cool. So what will happen? We'll collect the bright blue crystals of copper sulfate, which is your CuSO4. That's why copper sulfate is also known as the blue vitriol. Okay?
Okay.
So tell me, what is the procedure of iron chloride? Not
I
this one. Iron chloride.
some ma'am, there is powder.
What?
Ma'am, there's a beaker with water in it, and there's a iron wire,
Hmm.
and there's chloride put into it.
Dry chlorine gas.
Yeah, dry chloride gas, and then during this process, the iron wire heats up because
Hmm.
energy is made, and this is why it's an exothermic reaction.
Okay. And what about this copper sulfate?
And copper sulfate is made of copper hydroxide.
Hmm.
Uh,
Oxide or carbonate, and we have to keep the dilute acid in the beaker, and then we have to mix a copper hydroxide, and then we have to stir it, right?
yes, ma'am.
Like that. Okay, so we have to stir the solution, and then at last what we will collect? We'll collect the bright blue crystals. So that's why this whole is known as the blue vitriol. Okay. Okay, next is this zinc sulfate. So how to prepare zinc sulfate? See, zinc sulfate is known as the white vitriol. Copper sulfate is known as the blue vitriol. Zinc sulfate is known as the white vitriol. And how to prepare a zinc sulfate? We have to treat any zinc material with the sulfuric acid. ठीक है? अगर हम लोग क्या करेंगे, if we will treat any of the zinc with sulfuric acid, which is H2SO4, so what we will get? We will get zinc sulfate. Now what's the procedure? The procedure for the preparation is the same as the zinc sulfate. Huh. Okay, so this is same as the iron sulfate, and pale green crystal are formed. There was blue vitriol, and here was pale green crystals. Now the calcium carbonate, which is CaCO3, so it is formed with the help of the three main elements, which is your carbon, oxygen, and calcium. So here during the preparation, what we have to do? We have to mix the solution of a, what is this? This is the calcium chloride. And what is this? This is a sodium carbonate. So when we will mix these two, we'll get a calcium carbonate. And the formula of a calcium carbonate is the CaCO, CaCO3. And what's the procedure of this? So what we have to do? Dissolve excess of sodium carbonate solution to a hot solution of calcium carbonate. Again, same process, sodium carbonate with a calcium chloride. And what will happen? We at last it will give us a white precipitate formed. Okay? White color will form. So this is the process of a calcium carbonate. Here, pale green crystal, there was blue vitriol, and for the calcium carbonate, it will be of a white precipitate will form. So now lead chloride, lead is Pb. So here it is an inorganic compound with which is a PbCl2 and which is a white solid. Okay? This is what? This is a white solid. Now how to prepare this? It can be obtained by mixing of a lead nitrate. So here we are mixing a lead nitrate with a dilute HCl, dilute hydrochloric acid. So if we are mixing these two, what we are getting? We are getting a lead chloride, which is PbCl2. And what's the procedure to mix? So what we have to take? We have to take 5 grams of lead nitrate solution. This is your lead nitrate solution. And in how much ml of water? In 25 ml distilled water we have to take. Now we have to add some of the HCl to the lead nitrate solution. Then what will happen? We have to filter this with a cold water, and after that we have to dissolve this PbCl2 in the water. So at last what we will get? We will get PbCl2 in a pure crystal form. Next is your sodium bicarbonate. Sodium bicarbonate is a very fine powder and it prepares with the help of these three, which is your carbon dioxide, water, and what is Na2CO3? Sodium carbonate. Okay? So here we are taking 5 gram of sodium carbonate in a 25 ml of water in the beaker. Now we have to cool this solution, and at last we'll get the crystal. And in the next class, next Monday, I listen all these. Okay? Preparation be salt preparation also, and this is the laboratory preparation also. Because
Okay.
this is very important. You have to make notes point wise and you have to remember. And if that time you will not tell, then pakka suspend.
Mm.
Hmm?
I'm
So
done.
what?
I'll tell next class.
Yeah.
Ma'am, I promise I'll tell next class.
Okay. Good. So last is sodium sulfate crystal, which is Na2SO4. So how to prepare this? It is prepared by the neutralization of the caustic soda with sulfuric acid. This is your sulfuric acid. So when we will mix these two, we'll get a sodium sulfate crystal. And the procedure to do this is what? We have to take in a conical flask 25 centimeter cube of a sodium hydroxide solution we have to measure, and then what we have to do, we have to add some indicator which will turn into pink. The color of sodium hydroxide will turn into pink, and then it is filled with a dilute sulfuric acid which is okay, and then we have to note the reading. So the acid is then allowed to run into that flask until the solution turns colorless, because when we are adding the indicator it will turn into pink, and then we have to allow the acid to run into that particular conical flask until whole solution turns colorless. So this is known as the end point. Why end point? Because it is turning into colorless color, from pink into colorless. So at this point, what will happen? You will read the note. Note will be read. So the difference between the two readings, one was your pink and the second one was your colorless, is that the volume, what we have to read, the difference between of the two readings is what? Is the volume of a acid. So what will happen? The solution obtained after titration of your sodium sulfate and water, after that what will happen? Your crystals of this sodium sulfate crystals are obtained. So here we have to take a conical flask, and we have to add some indicator, so the solution will turn into pink, and then we have to add some dilute sulfuric acid, and we have to allow the acid until that into that conical flask until whole solution turns into colorless, and by the difference, and then we have to note the difference between one and second experiment. So the difference was what? Difference was the volume of the acid. So that's how we prepare this, and we'll get a crystal sodium sulfate. What is the general property of salt? So salts are what? They have a high melting point. They are non-volatile in nature. What is the meaning of a non-volatile? Means when they are exposed at the room temperature, they do not evaporate. है ना? If you are taking a salt in the room temperature, they do not evaporate. And they have a high melting point. They are what? they result into a formation of ionic compounds, which is salt is what NaCl. You know, they have greater force of attraction between molecules. If they have a greater force of attraction between molecules, means they are very tightly packed and the intermolecular forces are very high. So those substances that can remove water molecules even from the compounds are known as dehydrating agents. So that is also a property of your salt. Salts undergo into hydrolysis. If we'll take the ocean salt, then can we drink ocean salt? Like, can we eat ocean salt? No, right?
Now,
So this,
hydrolysis mean?
what, Ria?
What does hydrolysis mean?
Hydrolysis, you don't know?
No,
So
no.
here, okay, wait. So let me complete the sentence. So the salts, it's what? It's a phenomena due to which the salt of a strong acid and a weak base dissolves into water and reacts with it to form a parent acid and alkali. So basically, your hydrolysis is a form of a chemical reaction where waters are mostly used to break some of the chemical bonds which exist in that particular substances. Hmm.
Okay.
So with the help of the hydrolysis, what is happening here? So a salt which is of strong acid, we already covered that part, strong acid, weak acid, strong bases, है ना? So that all dissolves in water which will react into a salt, sorry, acid and alkali. ठीक? So are all salts soluble in water? Hmm?
No, ma'am.
No, salts are not soluble in water. If you'll mix salt with the water, what will happen?
All, not all of
They,
them.
they are soluble now.
Yes, ma'am.
Yes, they are soluble in water. Due to what? Due to the ionic compound which is present between the anion and a cation, because salt is Na plus and Cl minus. So here what will happen? All sulfides are insoluble in water. These are the exceptions, that all sulfides are insoluble. Sulfides are also insoluble. These also we covered. Carbonates are also insoluble in water. Okay? But soluble salts are all soluble in water. So with this, your chapter is completed, and I'll ask these preparation and laboratory preparation. And if you will not tell me answer, I will not start the third chapter. In school, which chapter is going on?
Ma'am, we started acids, bases, and so.
Acha, this unit only.
Yes, ma'am.
Okay. So quickly we will revise what is iron chloride. It is also known as a ferric chloride, which is dissolved in water and iron, which will go into hydrolysis. And this whole process is known as exothermic reaction. How to prepare this? We have to combine iron and chlorine to form a iron chloride. What is the procedure of this? So we have to pass the dry chlorine gas into a combustion tube. And what will happen? The combustion tube is slowly heated for a few minutes. And then a dry chlorine gas is passed through very slowly, and this whole process is known as the exothermic reaction. And what is copper sulfate? Copper sulfate is also known as blue vitriol. And how to prepare copper sulfate? We have to, what we have to do?
And
We have, huh,
we have to mix copper hydroxide,
yes,
copper oxide, or
hmm,
copper carbonate,
hmm,
H2SO.
with the dilute acid, right? And at last, what will happen? Will collect a bright blue crystal of a copper sulfate. And the next was your pale green color, which is zinc sulfate. Zinc sulfate is also known as blue vitriol. Here, how to prepare? Zinc sulfate is produced by treating what?
Any zinc
Ah,
compound with sulfuric acid.
with sulfuric acid, yes. And the pale green color are formed. What about calcium chloride?
And calcium chloride is made of
Three main elements, carbon.
calcium, oxygen, and carbon.
Yes. And how to prepare this? What reactions are involved?
Ma'am, uh, calcium chloride and sodium carbonate.
Yes. If we'll mix calcium chloride and sodium carbonate, what we will get? We will get a calcium carbonate plus NaCl. What about lead chloride? What is the procedure? So tell me, what is the procedure of a lead chloride?
Ma'am, making. Ma'am,
What procedure?
lead chloride is made of lead nitrate and diluted hydrofluoric acid.
Hmm. So here we have to take 5 grams of lead nitrate and we have to dissolve in a 25 ml distilled water, right?
Yes, ma'am.
And allow it to cool, and then what will happen? Your pure crystal will form. What about sodium bicarbonate?
Ma'am,
Here we have to
sodium bicarbonate is prepared by carbon dioxide gas and
with the sodium carbonate, right?
yes, ma'am.
5 grams of sodium carbonate in a 25 ml of your distilled water in a beaker. Okay.
Yes, ma'am.
And what is the last part? Sodium sulfate crystal. Here, what is the procedure of sodium sulfate crystal?
Ma'am, it's made of caustic
It
soda.
was easy now. First, we have to add an indicator so that it will turn into pink.
Yes,
And
ma'am.
then what we have to do, we have to allow the acid to run into the conical flasks. So what will happen? Your solution will turn into colorless color. So this was the end point of your conical flask. And then we have to note the readings of the first experiment and the second experiment. So what's the difference between these two? The volume of the acid, correct?
Okay.
What is the general properties of salt we discussed? That salts are non-volatile in nature. What is the meaning of non-volatile? That when it is exposed at the room temperature, it will not evaporate.
Okay.
It will have a high melting point. So you have to learn all these points.
Okay.
And
Are you gonna ask this next class?
what?
Are you going to ask this next?
Yes, all the points.
Okay. And
After that only I'll start third chapter, because these are important now. If you will miss all these, then what's the point of learning?
okay.
And salts are undergo into hydrolysis. And are all salts are soluble in water? Yes, all the salts are soluble in water except sulfide, and carbonate. These three salts are insoluble in water. And also you have to write the example. What are sulfides salt? So Na2SO3, K2SO3, NH4 whole twice SO3. These are sulfides salt which are insoluble in water. These are sulfides, and these are carbonate salts which are insoluble in water. Okay?
Okay.
Okay. So with this, we are done. And all the assignments are also you submitted now, Ria, in the Alamkul app. Please check once again.
Ma'am, may I check my phone?
Ha.
Ma'am, was there any assignment last week?
No.
Ma'am, then I would have done all of them. One
Wait,
second.
let me also check once again. ABS, AV3. No, acha, this you submitted, Shazan.
Yes, ma'am, I submitted.
You submitted.
Yes.
Yeah, done.
Yes.
So, any doubt in this chapter, Ria?
No, ma'am.
What we discussed: acid, base, salt, properties, physical properties, chemical properties. In chemical properties, see how many subtopics are there. Reaction with metals, metal oxides, chlorides, nitrates. Very much, na?
Yes, ma'am.
Uses of acids, uses of bases, indicators we discussed, that there are three types of indicators. What are they? What are the three types of indicators?
Uh,
Hmm.
what name?
What?
Uh, ma'am,
What are the three? Tell.
ma'am, I forgot. Ma'am, this China day.
What?
Ma'am, do I have to tell indicators, name of indicators?
There are four types of indicators: natural,
It's natural.
synthetic, olfactory, and universal. In the next class, I will also one second. I will also check the notes. You have to prepare all the points. You have to write down all the points. That what are natural indicators? What is the meaning of olfactory? Olfactory means odor, which is your smell. Hmm. What is universal indicator? What is pH value? Types of indicators. These are the types. So if red litmus is dipped into acid, what will happen is there will be any change?
Ma'am, the red litmus for acid will have no change, but for base will become blue.
Yes. And for the methyl orange, in the acid, it will turn into red, and in the base, it will turn into yellow color. So these are the strength. 7 is your neutral. And if you will go 8, 9, 10, what will happen? What will happen?
Ma'am, will be a base.
And below 7?
acid.
Yes. Acha, one is more acidic or six?
Ma'am,
One is more acidic or six? One first number
one
is more
is more acidic.
what?
One is more acidic.
Yes, one is more very good. So these are the pH value. One, two numericals also we discussed. So what are the factors affecting dilution, dissociation? These are the factors affecting pH value. Importance of pH value is also important. There were how many types? What's the importance? Plants and animals in the digestive system. There's also important. So tell me how pH is important for our digestion.
Ma'am, we have HCl in our stomach,
Hmm.
which is an acid, and
Hmm.
ma'am, if the HCl in our stomach becomes too much, a person has acidity, and to
Yeah.
prevent, no, ma'am, if a person has acidity, to like a medicine to it would be antacid
Hmm.
antacids, which are taken to lower the HCl level in the stomach.
Yes. So what will happen during indigestion? The stomach will produce too much acids. है ना? If too much acid stomach will produce, so we have to correct the pH value also of our stomach. So we have to take a mild base, which is also used as a medicine, or we can take ENO. So these are known as the antacid. ठीक है?
Okay.
For teeth also है ना, tooth decay, so the paste which we use with that's made up of base. Yes. Universal indicator we discussed. Salts, normal salts, acidic, basic, strong salts, weak salts, sorry, strong acids, weak acids, strong base, weak base. We have discussed all these. So you have to prepare these notes also, okay, Ria? That preparation of a normal salt, how many processes there from from soluble, insoluble, and in the soluble, how many subtopics are there? There are three: direct combustion, direct combination, displacement, decomposition, and within a decomposition, you have three reactions with metal carbonates, bicarbonate, sulfides, bisulfides, and a sulfide.
Okay.
And from insoluble, there are also three reaction combination, combination of acidic oxide, and last is your precipitation reaction. Common salt is caustic soda. We also discussed that caustic soda. What will happen when electricity is passed through your like aqueous solution, which is also known as the brine solution, because sodium and chlorine is mixed. So what will happen? Sodium hydroxide will form. Okay.
Okay.
Caustic soda is sodium hydroxide, which is NaOH. And you have to learn all the chemical formulas of bleaching powder, baking soda, plaster of Paris, caustic soda, laboratory preparation we discussed today, iron, copper, lead, calcium, zinc. Okay, so make a notes and remember all these points.
Okay.
And I will listen. No excuses.
Okay. I'll prepare and come on Monday.
All tests are done in school.
Ma'am, there's no, ma'am, for the previous chapter, yes, test is done.
Oh, okay. So that's it for this, for the chapter. That chapter is done. Any more doubt?
No, ma'am.